Alright, so today we were supposed to talk about the bitmap file format, right? And we will write a program that will read a bitmap file, and we can also write to a bitmap file. We will do all of this. But first of all, this will be a little bit of a recap as well. We need to understand what's going on. Okay? So this file, for example, this beetroot file that I used in our last class, I showed you that if you zoom up to a certain level, what you'd see are all pixels. And each of these pixels, they have red, green, and blue values. It's easy to understand if you pick any of these values and look at the color. We see the RGB values. This is 160, 117, 124. Okay, these are the values written right over here. Now we are reading this, all of it, from a, what's this file? Probably a PNG file, I guess. Oh no, JPG file. So we're reading from a JPEG file, and we can zoom up to see what are the colors. Now since we're using a image manipulation program like here, we also see the resolution of the file. This is 1920 by 1080, and we see a lot of colors. So since this is a JPEG file format, it's using some sort of compression algorithm to compress the data and to reduce the file size. In our last class I said for bitmap file, it's also possible to use some form of compression. To start with, let us look at a very simplified scenario. We're looking at a bitmap file, and we will try to make some sense out of it. So let us just create this file right over here. It's going to be a new file, and I want to create a small one. Okay. That we can process quite quickly. Okay. Now, this is a very simple picture file. It's all white. I want to make some changes over here, and in order to do that, I will pick a solid color to start with. This is going to be purely red, 255 for red. That's all intensity for red. No green, no blue. So this color is purely red. Is that clear? And we are going to paint it somewhere over here on this corner. Okay, so if you look at this corner, this is all red. Okay. The reason I'm doing so is I want to track whether we are reading the right thing. Okay. So in a similar fashion, I'm going to create a purely green color, and let us paint it over here. So part of this picture is purely green, and let us create this blue color over here as well. Okay, so that's blue, and I will create a black color as well. So we got 4 corners over here, and we have placed 4 different colors on this picture. Let me save this thing. I'm not saving it as a PNG file. I will save it as a bitmap file, BMP. So there are some compatibility options. I'm not dealing with color spaces. Bitmap has a particular way where you can say that I have a fixed set of colors, I'm only going to use those. Those are called index colors. I'm not going to go for that. What I'm going to do though, I will use 24 bits per pixel. And over here, in that 24 bits, it's written as R8, G8, B8, which means we will have 8 pixels for red, 8 pixels for green, and 8 pixels for blue. So altogether, that's a single number, but that one number is going to represent a color. Okay. So let us export this. We have our bitmap file. I didn't even notice where I saved that. It's in my documents. Okay. So let us go over here to documents. So we got our test.bmp file. Now we are trying to read this thing, right? And I will try to read this thing without an image editor because we're going to write a program to understand what goes in. So we have a tool on Linux. The tool is cat. It's short for concatenate. To read one file after another, that's what we use. Okay, so we're going to use that cat tool. So this is our picture. It doesn't look like red, green, and blue and black. Okay, none of these things make sense, and we really need to understand what goes on. So since it just flew away, I couldn't read the entire thing. Let me use a text editor over here to read this file. Okay, and again we can see the same thing. This is not readable at all, except for the very first two letters. It says BM. And any bitmap file will start with those two letters, BM. That stands for bitmap. Now if you open up a JPEG file or a PNG file or a GIF file, they will have a different structure. Now we don't know exactly what that format is. We have to look at the structure of the file, and you can look for standards, how those files are written, and then try to understand everything from there. See over here, that BM, it doesn't really denote any color information. Like I said, that's going to be fixed. So definitely it's not going to tell you any color. It just tells you that the file that you're opening is a bitmap file. And everything in between is written purely binary. So it's very hard to read. Definitely it's not readable at this point. But when we read it through a program, we will see a lot of numbers. They will mean something. So all these file formats, they have something in common. They have a header part where we have metadata about the file itself, and then we have the image data. Metadata simply means data about the data. So since we're dealing with this bitmap file format, what I did right at the beginning of the class, I went to Google and searched for bitmap file format. And you can read it from many different blog entries, many different sources. It's defined in many places. Okay. What I found is that the Wikipedia article, it is quite helpful, and it comes with a nice picture that actually shows you the entire structure of this thing. See, what happens over here, we have a bitmap file header where there is a signature. The signature itself is BM. Okay. If you scroll down, this is a pretty long picture going vertically down, so I can't really show you the whole thing in one place. Well, I could, but it's not readable. Okay. If you scroll down right at the bottom, you'd see the byte offset. Okay, so this is byte 0, this is byte 1, byte 2, and so it goes. Now, if you go to the top now, you see right over here, this is 0 and 1. So in 2 bytes, we have those two letters, B and M. And then we have 1, 2, 3, and 4. In 4 bytes, we have the size of the file written. So first of all, we have to read the first 2 bytes. That will tell us that this is a bitmap file. It's of no use, because we know already that this is a bitmap file. But if you're writing an image processing tool that has to deal with many different file formats, maybe that helps, because once you read the file's first 2 bytes, then you know what type of file it is. So the file size is important because you need to know exactly how much you're going to read. Well, this can also be externally available. The operating system itself can tell you exactly what's the file size. Can your operating system tell you what's the width of the image or the height of the image? It cannot without reading the file itself. We don't need to know the file size to, you don't have to read the entire file to know the file size. Okay? If you look at your file manager, you readily know the file size. You can also know the width and height of the image if your file manager is smart enough, if it reads through the image. We have a lot of file managers that actually show you the preview. You see the thumbnail. Yeah. Let us just do that. Even on Linux, I mean, this is pretty good. You see the preview over here, and since this is an image file, the operating system knows that, but it actually goes inside that image and finds out that this is 1920 by 1080 pixels. So if you go to my documents over here, the file that we created is 200 pixels wide, 300 pixels high. Okay, so that information is written over here, but they found that information by reading through the header part. Okay, so if you scroll down further over here, somewhere over here it says what's the width of the image and what's the height of the image. Okay, so in order to go through all of that, like, you have to count all these bytes, exactly where the height is written, where the width is written. If you know that, you can find that information out. And for this Wikipedia entry, I'll ask you guys to look at this table. Yeah, this one. This one down here where it says Windows Bitmap Info Header. It's written all in one place, and it's easy to find out, because now you see that the size of this info header is 40 bytes long, and from byte number 18 in 4 bytes we have the width of the image written. From byte number 22 with 4 bytes you have the height of the picture written. So we got 2 classes back to back, and we will need all of that to read and write and everything. So it's going to be a long process. I want you guys to bear with me, and if you don't understand anything, stop me right away. Because if you get lost, it's going to be very hard to come back to this thing again. Okay. So what we are going to do today, we're going to write a very simple program that reads byte after byte, and we're going to jump around over here because, let's say, we need to know the width information, or we need to know the height information, but we don't need anything else. So we will jump right to byte number 18, or we will jump right to byte number 22 and read from there. It's going to be random access. So we're going to read the entire file all in one go, store it in a buffer, and then start reading from there. Once we are ready, then we can deal with the color information. In our last class I said that everything is written in RGB, red, green, and blue. Okay? So we will try to make sense of that. But before even we get there, we need to understand exactly how things are written. So to make our life easier, I asked you guys to have some practice, have some knowledge about how to read and how to write in the language that we choose. Which one did we choose? I myself, I don't know how to write in Python, but I will write this program here in Python. If it were Java, then life would be much easier for me. It's no big deal. I mean, I tried it out obviously before coming to class, and it didn't take much effort. Me not knowing Python, I could write this program. So if you're in the same boat that you don't know Python, it's not really a big deal. I mean, you should be able to follow it. And if we get stuck somewhere, like, I mean, we can always look up a particular function, how to do things. We will look from there. Okay. So yeah, now that we have our image ready, let us go and have a look at it. Right now we tried to read it with the tools that we have in our OS, and it doesn't really make sense. So let us just write a program and see if we can make any sense out of it at all. Okay. Now, we need some IDE or some plain vanilla editor to write our program. And it goes for any other language, right? So what we can do is we can use PyCharm. I think all of you guys got PyCharm installed on your PCs. Can you guys please quickly check? Just go to the start menu and type in PyCharm. It's an IDE by JetBrains. Okay. Do we have it?
Yes, but it's an official version. It's not allowed us to use after the trial version.
Expert version.
Yes, sir. Professional version is trial, so you cannot use this way. We have also the professional version, right?
Yeah, I have the professional
Community version.
Well, you guys can download the community version. Well, tell you what. Do we have VS Code? Visual Studio Code? Just search for code, this Visual Studio Code thing. Or if not, I mean, just download the community edition and start install that on your PC for now. I do have the professional one because I have a license for it, and I just use mine. What I can do is I can create an account for you guys and share the password with the class so that you guys can install it on your PC. The professional one if you want, or you can use the community one as well, because we're not using any particular framework for this. Whatever we are doing is going to be very simple. For installing it on the PC, just a bit. Hello. আপনাদের যে PyCharm সবগুলো তো লাইসেন্স এক্সপায়ার করে দিচ্ছে লাইব্রেরিগুলো। Okay, I call for the lab assistant. He will come and have a look at it. I asked him to install these things over here. But for now, let me just write these things over here, and I guess you guys can follow. And once your PyCharm is fixed, I'll ask you guys to try these things on your own, on your PC. So you could use PyCharm or any other editor of your choice. I don't really use PyCharm myself. I mean, whatever small Python code I have to write, I usually write them on Visual Studio Code. It's much simpler, but since we have PyCharm installed, that's what I thought that we have, so I went for that. Now over here, let me create this, since we're writing a lot of programs, we're going to write that. Let me create a new folder, and let us call this, let me do it this way. Let me create a GitHub repository because I need to upload the code anyways. Is it working? Okay, then that's good. Okay. So, well, if you got PyCharm installed, then that's really good that we can run this thing together. I'm going to create a new project. I just wanted to see whether PyCharm is working over here. That's my Hello World program and it works. So let me create this new thing. Or actually let me start right from the scratch. I mean, this is what you'd get when you start PyCharm. When you install PyCharm and you start from the first time, this is what you're going to get. So we are going to create a new project and it's going to be a pure Python project. Okay. I'm going to put this thing into my summer 2018 IP, and over here this is going to be our BMP reader project. Alright, well, let me just call it BMP reader. It's also going to be a BMP writer, but I think this makes more sense. Initially we will simply read from this thing. Okay. So it's going to take a little bit of time to set everything up. We don't have any file yet. We don't have any source file yet. So that's the first thing we are going to create. Let us go for new. Well, not yet. So this is going to be a new Python file, and we will call this, let's say, bitmap.py. Okay. And just to make sure that this is working, so I'll try the same thing. Print hello world, or better yet, hello image processing. Okay. And we need to run this program, and you need to edit the configuration to say how you're going to run this thing. Okay. Or you could also run it from the command line. Okay. Let me show you both the versions. So if you're going to use a command line right along with it, you can jump right into the directory. So this is our bitmap reader, and we have bitmap.py. We will simply say Python 3. We're going to use version 3.6 over here. Python 2.7 and 3.6 is a little bit different in terms of the way you call the functions. So let me be very specific that we're going to use Python 3, and we will say bitmap.py. So when you hit that, when you run through the interpreter right here on the command line, it works. Okay. But most often, I'd like to see the output right from here. That's why I will go into the edit configuration. I will click on the plus button to create a new configuration, and that's going to be based on Python. Let me give it a name. It says run project, or you could give it your own name. I mean, it's up to you. And then we have to browse and show where that file is. Okay, so that's our PyCharm projects directory. Right under that we have summer 2018 IP, BMP reader, and then bitmap.py. Okay. So once we edit that configuration, we have this run button over here, and now we can run it from within that IDE. Okay, so it can be a little bit convenient that way. So either this or that, and it doesn't really need any IDE. Let me just show you that you could use this thing, this text editor, save your file, and then run it like that, and it works. Okay, so even without the IDE, you're not totally lost. It's just that having an IDE helps. Okay, so this is nothing about image processing at all, except for those two letters. Now, what I would like to do is I want to open this file that I just created with 4 different colors in 4 corners, and then read different parts of that file. Okay. So where's that file? Let me bring that into the same place so that it's a little bit more convenient for me. PyCharm projects, summer 2018 IP, and we got test.bmp. Okay, so it's in the same directory. I don't have to go for another path to look for this file. That's the only change I made. Now, instead of printing hello IP, let me leave it there for now. But what I want to do is I want to open this file and start reading from there. Okay. In Python, I mean, for those of us who don't know Python, we don't have to declare data type and then a variable. You just write the name of the variable and then you call a function, or you write a statement, or do whatever. Okay. So we have this function called open that lets you open a file. Okay. The file that we want to open is called test.bmp, and we want to open it in read mode, right? So R for reading, and since this is a binary file, we have to read it as binary as well. So RB. Okay. Now we have opened this file, and we have to read byte after byte and see what value we get. So right now what I'm going to do is I will try reading. There can be some exceptions, we can catch them. And finally we need to close the connection to this file. We need to free up the resources. This is pretty much the same with many other languages which follow the same style. Like even in Java, you try reading something and then finally you close the file connection. So this is not going to be anything different over here. Let us try to read a single byte. Okay. The way we do that, we say file.read. Okay. And we're going to read just one byte. We will write it into something called, well, whatever. I probably made a mistake over here. No? Why do I need self? Self is n equal to 1. That should be okay. Okay. Print. Try and finally file.close. Okay, so it was okay actually. So I'm trying to read one single byte, and I'm trying to print that value, whatever I read, and then I'm closing the file. That's it. Okay, let us run this thing. What do we get? We have a lowercase b and we have uppercase b. Alright, let us try to do this thing one more time. Okay, so I'm reading one byte again and putting it in the same place in val and then printing that. So that lowercase b thing seems to be common, but we have uppercase b and uppercase m. And that's exactly what we were expecting, that when you read the first 2 bytes, you're supposed to get bm, that's the signature. How do I know that? Well, from reading the Wikipedia entry where we have the bitmap file format specified, the signature has 2 bytes. And if you read through this, you'll see somewhere, yeah, the header file, we have possible values, it says bm. Is this thing clear? So we read this first 2 byte, and the lowercase b over here, it simply indicates that you're actually reading a byte. The output right there says b for byte. Okay. But like I said, that I want to read the entire content of the file into one array and then use that for some purpose. Let us try to do that. Or let me show you over here. If I try to read 2 bytes over here initially, then what do we get? See? We get 2 bytes. We got bm, and the next byte we read, it's a, what's that for? /x. it's a hexadecimal value, we get 9A. Okay. Alright, so how many bytes we're going to read? It depends on the file size. See, if you type in ls minus l, you get the file size in number of bytes, okay, in Linux. Or if you use LH, that's the human readable one. When we see kilobytes or megabytes or gigabytes, that's the thing. But what I really want to know, it's what's the file size, and I can copy from here and I can put it over here. Okay, so that's the number of bytes I want to read at one go, and everything will be stored in something called val.
Sir, faster read করলাম একবার পরে আবার read করলাম একবার মানে শুধু ওয়ার্ক থেকে আবার read করতেছি
Yes, that's how it is. And it's the same thing in Java as well. Once you start reading, the file pointer keeps on moving over. Okay. But we don't need to be concerned with that, because the way we are doing this, we are reading everything in one go. We will read the entire file in one go, and that's it. We'll be done with that. Okay. Now here's a problem. Like, I mean, I have this test.bmp, right? And if I want to read a different file, like that bitroot file, the file size will be different. So the file name obviously will be different. The file size will be different. I mean, it's definitely a very bad programming practice where we write these things all hard-coded inside, right? So the file name probably is better stored in a variable. Maybe we will read that from the user. Maybe we will show a file chooser dialog. But those are fancy stuff. We will look at that later on. But at least once the file name is given, we don't need to find out the file size by ourselves. Okay. We can find that file size and plug that in so that we can read the entire thing all in one go. So let me try to do a little bit better things over here. File name over here, test.bmp, we have that written. So this is the file name. Okay. And over here I want to pass the size of the file. Now, how do we find the file size? Well, actually not like that. You need some more help than that. Okay, we will have to import the OS class, because all these things are defined over there. So if you say os.path and then pass the file's name, here, what was that? Size or something. Let me just check. I mean, this is not my native language, so I get stuck in many places and I just look things up. Alright, so somehow we can find the size of this thing. Let me just check over here. Python 3. What's that? No, since I'm staying within the same directory, I don't need that. I tested that out. File size. File size. I'll check file size over here. So they have used stat over here, but even without that, path.getSize. Path.getSize and then the file name. And that's what I lost over here. Path.getSize and then the file name. Alright, now that's going to work. So just to make sure that we got it right, let me print this out. Okay. So yeah, 180, 122, that's exactly what we had, and it prints it out. Yeah, we're reading everything in binary. That's a more convenient way of showing that. Let me clarify this thing. See, if you wanted to write everything like on the console in binary, that would have been much harder to read. But if you write something like this, so let me take one example. Let's say I have, this is 5, right? And what's this? This is 12. Okay, so how many bits have I used over here? 8 bits. Okay, so if I write all these things one after another, it's hard to read. Okay, whereas if you write this thing in hexadecimal, this would be 5, A is 10, B is 12, and this is C, 5C. And so this is much easier to read, so we tend to write things in binary over here. Now all these things, that's how many bytes, how many bits? 8 bits. That's why this is one byte. Okay, and 1 byte is typically written in 2 hexadecimal symbols, and that's exactly what you see down here. Okay, so one over here, that's 1 byte, this is another byte, this is another byte, and so it goes. Is this thing clear? Okay. Now the first two entries over here, byte 0 and byte 1, they definitely make sense, right? What are those? Those are B and M. Okay. One thing I'd like to do over here, since we're printing this out, okay, and they're coming out in this form, this is still maybe a little bit difficult for us to understand because we're used to looking at numbers in decimal, not in hexadecimal. Okay, so let me convert this for you. When we read this thing, when we assign this over here, let me throw it in a byte array. Okay, I'll just rename this thing. I'll call this byte array. Okay. The renaming part wasn't really important, just to make sure that we got the idea right. We have an array of numbers, and each number can be from 0 to 255. That's exactly the maximum value that you can have in a byte. So we have this byte array, and now we are printing this out in terms of byte. Let me check this out. Byte array 0. See, what do we get? 66. So if we get byte array, let me leave it over here. Sure. Byte array 3. Did you want to see the output over here for 3? Sure, why not? So we got 66, 77, 191. Now, why do we have 66 and 77? 66 is for B, and 77, that's for M. Those are the ASCII values. If you remember all the way back to programming language C, where you learned ASCII values, uppercase A was 65, so uppercase B definitely was 66. Okay, so that's why we got 66 over here, and I don't really want to count, but you can count and make sure that this is M. This is actually M. Alright, so that's that. So what I want you guys to understand is that we have stored all these things into something called a byte array. Everything in Python is in list. In whatever I'm saying array, I just want to make sure that this is easy for us to understand. But in reality that's also a list. Okay? So we have this list or array which we can go through with indices, that we have read everything in a byte array, and individually we can read each and every item, and they're just simple numbers. Each of these numbers can be from 0 to 255. Okay. The first challenge for us is to understand how can we get back the actual number when it's written in multiple bytes. See? This one is not a challenge. This B and this M is not a challenge because it itself stands on its own. 66 is B, it's easy to understand. 77, that's M, we know that. Okay? That's fine and dandy, but if you look at this picture itself, when you go to BMP file format, see the file size is written over here, and it starts let me just have a quick look. Okay, so offset in decimal is given over here. From byte number 2, in 4 bytes, we have the size of the bitmap. What's the size of the bitmap? In terms of bytes?
That's 1.
Yeah, 180,122 bytes. That's the size of this bitmap. Okay. And what do we see over here? Starting from byte number 2 to byte number 4, we have this thing. So instead of printing byte 0 and byte 1, if I printed byte 2, byte 3, byte 4, and byte 5, 2, 3, 4, 5, I should get 180122. Is this not clear? Is this what we get? What's that? Yeah, it is also possible to write it in a much better way. I mean, this line number 13, the way I have written byte array 2, 3, 4, and 5, we could have written it in a simpler way. I'm going to do that. But it's more important to understand that we have 4 different values that should actually make up this number. These two should be the same thing. Right now they're not. How can they be the same thing?
Just need to convert it to hexadecimal.
We can definitely convert it into hexadecimal. We actually have it converted into hexadecimal. This is the first one, this is the second one. And then these 4, see, 9A is 154, BF is 191, 2 is 200. So we do have exactly the same thing written down in hexadecimal. Right now we have it in decimal. I purposefully brought it out in decimal just to make sure that you got it, the idea right. It's easier for us to understand. This entire thing, whatever we have written, 154, 191, 2 and 0, should actually make that number. And how is that possible? Okay, so let me try this out. See if we got this idea. This actually goes back to digital logic design and maybe part of computer architecture. I mean, you guys must have covered these things over there, or even in computer fundamentals, really. So we got 9A, right? And you have to know how this is written, otherwise you wouldn't understand. This is written with the least significant byte right in front. So when I'm writing it down, you can probably imagine that this is written in Arabic, but right now I'm writing this thing in English. Okay, so 9A comes over here. This is the least significant one. Just a second. হ্যালো সমস্যা পারবেন হয়তো, কিন্তু ওই যে সার্ভারটা বোধহয় আশিক ডাউন করে রাখছে, কিছু মেনটেন্যান্সে কাজ করতেছিল। না, আরেকদিন আসতে বলেছে সেই। হ্যাঁ পারবে, ওই কোনো সময় টাইম নেই। হ্যাঁ স্যার ক্লাসে আছে। Okay. So I have written down exactly the same numbers, but I have written it down in a different direction. 9A, BF, 0200 from right to left, because the least significant bit, we are used to writing that on the right side. Okay. They have a very good reason for writing it in this way. In computer architecture, you probably heard about two different terms, little endian and big endian. It's the endianness, the order of the bytes, how you write it in your storage or memory. So when we write this like this, we have 4 bytes, right? It's a 32-bit number. Each byte is 8 bits. Since we have 4 such bytes, that's 32 bits. Can we write 9A? What's A? A is 10, right? 10 in binary is 1010. What's 9? That's that. What's F? 4 ones. What's B? We have written that, well, that's 11, right? 1, 1, 0, and 1. This is 2, right? So this is 0, 0, 1, 0, and the remaining bits, what are they? What's that?
1 was 0.
0, 1, 1. Right, that was a mistake. 1, 0, 1, 1. What's this? This is 9. This is 10, and what do we have?
B.
B. 11. Right. So now it's correct. Thank you. That was a mistake. So now we have the entire thing written in binary. I skipped the zeros. No big deal, right? I mean, you can just write zeros. How many zeros? Well, 12 zeros. But no point in doing so. Okay, so if you could convert this into decimal, it should come out to be 180,122. Okay. How do we check this? It's easy. Yeah, just bring out the calculator and set it to maybe programming mode, and let us write some binary over here. I could also write it in hexadecimal, and maybe that would be easier, but let me do that anyways. I don't know if you can see this here. See, this entire thing, whatever we have written in binary, the decimal equivalent is actually 180, 122. So whatever we have in the file is actually correct. Now the only challenge is how do you find the number? It's already written like that, but how do you find the number? These are written in 4 parts. We have one number over here, we have another number over here, we have another number over here, and another one over here. These are 4 individual numbers, and we need to convert that to get 180 out, 180, 122 out. Okay. Now you could say that I can read these numbers like 9A, BF, 02. I can read individually all these numbers. I can make a make a huge binary string, and then I can convert that using the computer fundamentals technique, whatever we have learned, using powers of 2, right? And I would say that that would work, but that's going to be a very bad approach. Okay, we can do much better than that. And in order to understand exactly what we're going to do, you need to understand that we are not limited to base 2 or base 8, base 16 or base 10. We're not limited to that. If you can bring yourself out of that box, life will be so much easier. Okay, so let me write down the decimal numbers just like that. Okay, and let us forget everything about image processing and all these bitmap files for a bit, and let us work with decimal numbers for now. Say 125 written in decimal number. How do we find the value 125 over here? We have only written down 1, 2, and 5 side by side. See, all these digits, they have positional values. So 1, 2, 5, they all have positional values. And in order to find out exactly the value of the entire thing, the entire number, what we do is exactly what you did to convert any number from binary to decimal. You multiply 5 with 10 to the power 0, because that's the units place. This is the tens place. This is the hundreds place. You multiply 2 with 10 to the power what? And you add 1 into 10 to the power 2. So 10 to the power 2 is what? 100. That's 100 over here. This is ones. 10. 2 times 10 is 20. And this is 10 to the power 0 is what? 1. So 5 times 1 is 5. So if you add them all together, what do you get? 125. We do this because we are in a decimal number system. If you were in binary number system, what would you do? Instead of 10, you just use 2. That just makes sense, right? So if you look at the digit values, what are the different options that we get for digit values in a decimal number system? 0 to 9. We get 10 options. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All these 10 options we get for each of these digits. If that's clear, then let us just say that we have a new number system, only that this is in base what? Yes, 256. And that's why I said that you have to come out of the box, that we learn about base 2, we learn about base 8, 16, and 10. But base can be anything, really.
Yeah, we're treating something new.
No, it's not new. I mean, people have used that before. It's just that we haven't. Alright, base 256 is nothing new. Why this is like so? Like, I mean, it's not hard to understand. Just think about this thing as a single digit. 154. Think of it as a single digit. This 191, you can think about it as one single digit. What are the different options you got? 0, 1, 2, 3, up, all the way up to 255. That's altogether 256 different options. And just like you could do this thing before, that if you are given the digits side by side, you can convert them like so. Like we have 5, we have 2, we have 1. This is multiplied by 10 to the power 0. This is multiplied by 10 to the power 1. Then we have 10 to the power 2. If you understand this bit, help me out with the next one. What we have over here, how can we write this thing in exactly the same fashion? This 154 what should we multiply this by?
250 is divided by 0.
The base to the power 0 plus 191 into 256 to the power 1 and 2 into and the last one we can forget that because it's going to be multiplied with 0, but eventually it would actually be 0 into 256 to the power 3, and so it goes. If we had more digits like that, we could do that. So let us carry it out. I mean, I'm taking or wasting a lot of time, but I want you guys to understand this because we will use this concept in many places throughout the program. We will write one function and we will call that, but you need to understand what happens in there. So 256 to the power 0, what's that? 1, right? So we have this 154 multiplied by 1. Then what do we have over here? We got 191 multiplied by 256. And finally we got 2 multiplied by, I don't know what this is. (256 into 256), right? I should have known that. So 655 36. Okay. So if you add up everything together, this thing into 2, that's 131072. And this 191 into 256, that gives you 48,896. And finally we got 154. So if you add up all these things, okay, that's no magic, I mean that's exactly what you get. Tell me, is this thing clear? Okay. So this is nothing new, just plain old computer fundamental stuff. It's just that the base is different and we can calculate this thing. Turns out that we can rewrite this entire calculation. That's actually more computationally less expensive and at the same time easier to write programming. See, we know all these numbers right now. We know 0, we know 2, 191 and 154. We know individual numbers, and to find out the entire thing, we need to multiply with powers of 256. Okay? That's quite obvious.
Highest base formula that
It can be anything, really. Because we know already that individually all these values are in the range 0 to 255. What are the different choices that you have? You have 256 different choices. That's exactly the reason I asked you, how many choices do I have for a single digit in decimal number system? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 choices. For binary, you got 2 choices, 0 and 1. That's why the base is 2. Okay, so the point that I'm trying to make over here, see, we have 256 to the power 0, we have 256 to the power 1, 256 to the power 2. Okay? You can take these powers, well, the base common from here. See, we don't need to compute 256 to the power 2 really. Why? Because if you write this as 2 times 256 plus 191, you can actually achieve the same thing in one less multiplication, I'm talking about this part, are they the same?
Yes, sir. Yes.
Let us count the number of multiplications we have. Over here we got one multiplication, and over here we got one and another one, two, right? So altogether we had three multiplications, but in this line over here we got one multiplication, you do the addition and then do another multiplication, so two multiplications. So it will save one multiplication right away. Okay. The reason we are doing so, I mean, I said there are two reasons for doing so. One is we will save the multiplications. Multiplications are much more expensive than additions. And you don't have to be a rocket scientist to understand that. Plain and simple, some DLD knowledge will do. If you look at the adder circuit and if you look at the multiplier circuit, you know how many extra stuff you have to throw in there. So, how does this thing help? And I want you guys to look this up because this is important knowledge, really. This is actually called Horner's rule. Horner's rule is usually used for polynomial evaluation, but whatever we are doing exactly is the same thing. It's just that the polynomial is based on the base itself. So let us take a very simple example. Let us take base 10 as an example. Okay, and I'll go with the same number 1, 2, 5, but this time around I'm not going to write it as 1 into 10 to the power 2 plus 2 into 10 to the power 1 plus 5 into 10 to the power 0. Instead of doing so, let us say that I want to find this thing. This is given to me as a string or individual digits, and I want to make the number out of it. I want to find out exactly the value from here. How do we find that out? So this 125, just a bit. Hello? এই জিনিসটা এখন করা লাগলো খুব বাজে চয়েস হয়েছে আর কি ঠিক আছে না তারপর মানে এটা এখন না আর কি মানে সব কিছু শেষ হওয়ার পরে করলেও হইতো না আচ্ছা ঠিক আছে sorry about that. Okay, what I wanted to do, like we have 1, 2, and 5 individually. Let us treat them as individual digits. How can we find this number? It's a really simple trick, and I'm not going to write Horner's rule for you or the algorithm over here. It's very simple and easy to understand. Let us start with sum equal to 0. I want to get 125, but all I'm given is 1, 2, and 5. Okay, so what I'm going to do is a repeated process. I'll read this number, I'll multiply the initial value of sum by 10, and I'll just add this number. Right now sum is equal to 0. So what if I do sum into 10? That gives me 0. If I add 0 plus 1, what do I get? 1. So sum has 1 now. Going to the next digit, what am I going to do?
Plus 1.
I'll do the same thing. I'll multiply by 10 and then add this digit. So we got 1. 1 times 10 is what? 10. And sum becomes 10 plus 2. What's that? 12.
And multiply by 10.
Okay, so 12 times 10
120.
what's the final digit?
5 plus.
So sum is equal to 120 plus 5 equal to 125. Is this thing clear? It's a very simple process. You don't have to find the powers. You just carry on from left to right. Every time you multiply the current value of sum by 10, and then you just add in the digit. Okay. So we are multiplying by 10 because of what? Because of the base. This is in base 10. If it were base 16, we multiply by 16. If it were base 256, we simply multiply by 256. Is this whole thing clear? Then we can write a simple function that does this thing for us. Okay. So we're going to jump into that, but before doing so, let me do things in a slightly smarter way, like Johnny will said. So in Python, there is a nice feature. You could use indices. I want to start at index number 2, and I want to use 4 numbers one after another. So 2 plus 4 is 6. Okay, this is exclusive, this is inclusive. Okay, so you see that we get 4 entries right from there. Okay, so we can access that. One thing I want you guys to realize that we have a problem over here. See, the numbers we got are given in a reverse fashion. We want 0 first, then 2, then 191, and then 154. But what we are given, 154, 191, 2, and 0 in this way. And that's a bit of a problem. We need to reverse this, and then we need to run a loop through that. Or we could run a loop in the reverse direction. I mean, both of them would work. But for convenience, and since this is already available, why not do that? Did I spell it wrong? Yeah, reversed. Okay, so we can have it reversed and see. Well, let me write this out. I think that makes more sense this way. We will define a new method because we are going to use this thing quite a bit. Convert to integer, and what we will pass is an array, some sort of an array. All right. Okay, and it's going to return us the converted value. All right. So what we are going to do here, instead of printing this thing, I'll just call this thing convert to integer, and the call goes here. Is this thing clear? What's that? Yeah. We need to convert this number, right? From byte number 2 all the way to byte number 5. This 4-byte number, we need to convert that to a single integer. If you look at this thing, we will need to read the height of the picture, the width of the picture. So the same thing will pop up again. You need to convert 4 bytes into another integer. Over here, sometimes 2 bytes, sometimes 4 bytes. It could be something else either, 3 bytes. So rather than doing it separately all the time, what if we have a convert to integer method written for us, that if we pass, let me write it in this form, if the input to it is 154, 191, 0, well actually the other way around, since this is reversed already, 0 to 191, 154, if that's the input, it gives us an output of 180, 122. Is this thing clear? Okay, so this is what we are passing and this is what we are expecting as return. So, like I said, that we can write this thing in this form, that initially sum is going to be 0, right? And every time we keep on doing the same thing over and over again. How many times do we do that? For value in this array, for each of these values, what do? We don't need the index, and that's why I wrote it in this form. Value can be 0, value can be 2, value can be 191, and value can be 154. It takes one element at a time. This is like Java's enhanced for loop. You don't need to go for int I equal to 0, I less than this number, I plus plus. This is convenient if you're using a list. So in this list, it goes all the way from the beginning to the very end. Sum equal to sum into? No. 256, because this is the base. Sum equal to whatever the sum was plus, yeah, that's the value. So the first time the value is going to be 0, the next time the value is going to be 2, then 191, then 154. Every time this same thing happens. And that's this entire method. Okay, so I don't know if this works. Let us try this out. Let's say that's the computed file size, and let me print this out. And let us also print this over here. We have printed this. And that's the file size. So these two numbers should match, and this program should run. And yeah, it does. Are we okay so far? This wasn't really image processing to this point, it was just in plain math. Okay. So if you understand this bit, that we can understand this file size right from the file itself, that's written in there in binary form. If you know exactly which bytes to look at, you can find out the file size from here. Okay? If this part is clear, help me out. How can I find out the width of this image?
So which is from start from 6.
I need to find out the width of this image. Well, let us have a quick look at this thing. This is the image over here, and let me make this a little bit bigger. Well, it doesn't say anything over here, but yeah, 200 by 300, I remember that, and that's exactly what's written. Okay, so the answer I should get is 200. Okay, so what should I do? How do I know the width?
Byte it to 6 to 8.
2 bit for
With if
Well, that's the thing. I mean, this is nothing that we can invent. This has to be set in standards.
Yes.
Okay, so you have to come over here and look at the table to find out exactly where you're going to start reading from and how many bytes you're going to read.
it's 4 by 4.
So, what do you see over here?
Size 4 bytes.
What does that mean? How many bytes we have to read? We have to read 4 bytes. Starting from where?
Offset is the starting.
Yeah, offset is the starting.
We are reading hexadecimal, so 12.
Offset is 18, not 12. This is 18. You could write it in hexadecimal. If you started writing it in hexadecimal, that's what you pass in. But if you look at this thing, we used regular decimal numbers over here. The indices, they are indices. If you used hexadecimal numbers, then you would have used this first column. Since we are using decimal numbers, we are going to use the second column. Is this thing clear? So starting from 18, we have to read 4 bytes, and that gives us the width of this picture. Okay, so if I were to write this thing, width equal to, what should we call?
Reverse.
Convert to integer.
Reverse. Byte.
Byte array 18 to 22. Okay, so before going any further, let us just test this out whether it works or not. So width, and just run this thing. Says width 200, and that's fine. So once you have the basic thing set up, once you understand how to read these things, it's really very easy. But you got to understand why we did it in a certain fashion.
So I have a question.
Yep.
It says the file size in bytes, right? But width is given there in the properties is pixel. But
Yes, that's okay. I mean, that's the convention. I mean, you're reading the entire file, so you have to know the file size, and that's easier given in bytes. You have to be very specific, because when you look at the human readable thing like kilobytes or megabytes, that's an approximation. That's not the exact thing. When you go down to the byte level, that's the exact value, so you're going to use that. If you look at pixels, we go for the smallest unit that you can measure for a picture. You cannot go smaller than that. Okay, and I mean pixels, if you want to give the number of pixels in bytes, that doesn't make any sense. You're just giving a number. What's the number of pixels going horizontally, number of pixels going vertically? So that's just a number. Okay. So if you can do it for the width, you should be able to do it for the height as well. Okay. What numbers should we pick? 22 to 26. Okay. So let us say this is height. And we change this over here, 22 to 26. And we run this project, and we got width 200, height 300, all checks out. So we are on the right track. So far so good, right? So we should be ready to jump in right into the color part. The pixel data we should be able to read from there and maybe make some sense out of it. Okay. Any question with any of these things? Okay. Right now we have really used a horrible style of coding. Okay. Because we may be using this code for many different purposes. It would be much better to write a class out of it, create a data type called, let's say, bitmap, so that you can create your bitmap objects, bitmap A, B, C, and then read a file, write to a file, or do some intermediate operations like rotate left, rotate right, or let's say flip horizontally, flip vertically, and do all of that. We don't need any GIMP or Photoshop for that. I mean, we're writing our own program that will do all these things. And that's going to come soon. So, I mean, those are image processing stuff. We haven't been there yet. All we are doing is simply reading through the file yet. So, if this part is done, how can we read the color information? So, in order to do that, we need to know the offset from where the color data starts. Okay, and this is written somewhere. I'm skipping a lot of things, like the color table, the compression, all these things can be written into the header part, but since we're using a very simple format where there is no compression and there is no index color, we can skip those tables. But if you want to make it generic so that it works for any BMP file, you should actually handle all of that. I'm just not interested in it for now. Okay, so it's in this table, bitmap file header. Right here it says from offset 10, in 4 bytes, you have the starting address of the color data, the pixel data. So just in the same way, I'm going to compute this thing. I will just say
10 to 40.
data offset or pixel offset starts from 10, goes to 14. This is not the data. This is actually the starting address of the data. Okay, so what do we say? We say, well, data offset address. Data offset address is 122. So starting at byte number 122, that's where your pixel data starts. That's your pixel 00. Is this thing clear? Okay. So can we now read the red, green, and blue value for pixel 000? Okay. So we got three values, 3 bytes, RGB. This is a 24-bit system. For each pixel we got 3 bytes, red, green, and blue, one after another. Let us try to read this thing. Red is going to be byte array at the data offset. Okay. Then we got green. And finally we got blue. So data offset plus 0 bytes, data offset plus 1 byte, and data offset plus 2 bytes. Okay. And then we can print the values. Print red, green, and blue.
So I guess Python works with BGI.
Not Python. All these image processing algorithms. See, I mean, the image hasn't changed, so the data encoding is not dependent on your language. Alright, so we get 000. What color is that?
So what black?
Orange.
Black or white? We got to decide on one.
So black, because selection of blood is the black.
Black.
Yeah, that's what I did. What Mehdi is saying is right, because I mean, when we were creating this picture in GIMP, and it stays right there. See, that's a black color, all zeros. That's a black color. That also tells you, I mean, 000, where is that? Where is our 00? It's bottom left.
Left bottom.
Okay, so this is not 000, 00. This is 00. And we go this way. And if you go to BMP file format, you'd also know that. If you go down here, see, this is pixel 00. This is pixel 10, 20, and so on. Is this thing clear? Okay, so we write the width first, and then the row, then the height rather. It's packed that way. Okay. Okay. So wouldn't it be handy to find out the color value for any pixel? Can we write a function for that?
Yes.
Let us define a get color, and what we're going to pass over here.
So 2D array. Pixel.
We need the pixel values, right? So first of all, we need the byte array.
Yes.
Otherwise, how we are going to access this thing? And let me be a little bit specific over here. We pass the byte array, and then the row and column values, and you're supposed to get red, green, and blue back. Okay. So, for example, what we are going to call this method with, we will pass the byte array as it is, and say 00, and we will get 000 back as the color. Okay. So how do we get that? First of all, we need to know the data offset as well, right? So for now, just for convenience, let me pass the data offset as well. Okay. Red, green, and blue. This is how we computed that, and we can return them back. Now the problem with this is it's always going to work for 0, 0. See, we're not using row and column values. So we need to compute the actual offset. The actual offset starts at data offset. Okay, that's fine. But if you look at this picture, if I want to find out a color at this pixel, it will have a particular row value and a column value, which is not 0, 0. So how do we get there? And we started off over here. Goes like this, goes like that, and then it goes on. So at some point it would reach at this point. How do we find how many bytes we have already crossed to reach that thing? See, all these things are written in bytes, right? It's not in 2D anymore. It's a single one strip, 1D strip. So you can't stay in 2D anymore. So this is byte 0, byte 1, byte 2, byte 3, 4, 5, 6, 7, 8. 3 bytes together make up a single color, a single pixel. So if I'm going to point at this, I need to ensure that I have crossed all these bytes. How do I do that? That again needs a little bit of math. Well, yeah, the starting value I have already passed. I mean, this is not 0. This is actually 122. That gets added. What happens to the row and column? How many columns do we have in each row? For this particular picture, how many columns do we have for each row?
Each row.
200 columns for each row. If you look at this entire picture as a table, it has 200 columns and 300 rows. So let me take up a very specific example over here. If I wanted to say that I want to do a computation for row 10 and column 5, the offset that we're going to compute now there's a bad choice of color. The offset would be 122 to start with, okay? But for 10 rows, how many columns have we crossed? For each of those rows, I have crossed 200 columns. That's already gone. How many extra columns have I gone?
5.
That's all together, that's the offset. Okay? And for those of you who are still lost, let me try this out one more time. Let me see. See, we are going through the rows one at a time. So this is a row, this is another row, this is another row, right? We are crossing through all the columns over here. So when we get here to column number, say row number 10 and column number 5, what happens over here is this entire block, this part. How many rows are here? 10 rows. For each row we have 200 columns. That's that many bytes. And then 5 is over here. That's the number of pixels actually. Okay? And each pixel has how many bytes?
So it's 3 bytes.
3 bytes. So we have to multiply this guy with 3. Because this is red, green, and blue. That's 1 pixel. Red, green, and blue, another pixel. Red, green, and blue, another pixel. So it goes on. Is this thing clear? So in here we're going to do row into what do we need? We need the width plus column,
column of
okay? And this entire thing multiplied by 3. And here's another problem that we have to pass the width and maybe the height. And now you see that how ugly it becomes, that to call this function we have to pass all these things. Wouldn't be so much better if we could bunch up all these things into a single class and we could write it in a much more elegant way. We will move to that, but just for now, to test this out, let us bear this pain and see what we get. Alright, so for now, let us say this is red, green, and blue. And in Python, we can return multiple values in one go, just like that. Yeah. In that way, it's better than the other languages we typically use. Okay, so we could now say print get color, pass the byte array, pass the, what was that, the offset?
Offset with height
0, 0, and we should get oh, yeah, that was silly. Okay, so we get 0, 0, 0. Okay, now if you look at the last pixel over here, that's should be a blue one, right? That should be row number 0, but column number what? 199. If this is column number 0, this cannot be column number 200. This has to be 199. So we got 255.00, but we were saying that this is supposed to be red, green, and blue. But in reality, when you write the images, it's not written in RGB, it's written in BGR. Okay. We have to change one of these things, right? Red is not found in index number 0. Red is actually found in index number 2. Green is here, right in the middle. That's 1, that's fine. And blue is found in index number 0. So now 0, 0, 255, that's the blue color. And if you go for the other corners, you should be able to find this out properly. All good?
Yeah. So why did you keep that? Shop 255?
Yes. Yes. You can think about this thing as intensity level. 0 is total darkness and 255 is total brightness. Total darkness in red, total darkness in green, and total darkness in blue means that you have no color. That's total darkness, and that's why this is 0, 0, 0. Whereas if you bump it up all the way to 255 for all of it, that means that we got a white color. Okay?
data offset.
Which one?
Data offset.
Data offset is where you start writing these things. If you look at this entire picture, the byte information, the pixel values are not starting from byte number 0. It's starting from somewhere else. So we need to know where does it start. That's what it says. File offset to pixel array. Gives you an address. It's like a pointer concept in C. So you take that address, you jump to that point, and you start reading from there. 122 is that address. It's not going to be 122 for all the pictures. It can vary. So that's why we found out that offset, and then we can go. Is this thing clear? Okay. All right. So time to put everything in one place, and I'll try. I mean, how far we can go. We'll probably use the next class as well, but I'll leave part of it as a homework for you guys. We wanted to write a class because this is becoming more and more clumsy. I mean, you could put it in a class that it's going to be reusable, and you can put all these functions in one place. How do you define a class in Python? Class and then the name. All right, no big surprise over there. And then you can define all the functions that you need and all the attributes that we need. Where do we declare them? Like, I mean, if it were Java or C++, we'd write down the attributes one after another, right? Private int width, private int height. We could write something like that. In Python, we don't do that because we don't even declare the variables. But there is a concept called self that refers to the object itself, and you need that. Okay, so let me give you some idea. Okay, what are the things we need to define over here? For example, we need to define a function called read file. Given a file name, you should be able to read that file. Okay, so how do we read this thing? I have to steal some code from here. Okay. So this is going to be really bad, but let me try one thing at a time. Okay, so we're going to open this file. And then what? We need to find the file size. Okay. Now there are two things. If you want to store the file size as a part of this object, what do? Is you write self.filesize. Then this becomes a part of this object. And if you wanted to use this as a local variable to this method only, you don't write self. Okay. This is a little bit different from the other languages that we are used to, namely C++ and Java. It's not like that, but you have to be careful. I mean, it somewhat relates to this concept of C++ and Java, but even without writing this, we could understand that you're actually referring to an attribute of a class, but over here you have to be specific, that whether you're meaning some attribute of this class or you're meaning something else. Okay, so see, we got this class and we got some other methods. These methods are not part of this class. However, this read file is a method of this class. How do we know that? So, okay. All right, one thing at a time. Let us just test this out and see whether this is working or not. And for now, we are just going to print the file size of the file that we just read. Okay, so print reading from file name, print file size. Oh well, I already have that in place. So that's that. Okay. So we have started a class. We have defined a single method called read file, and let us store the file size over here. Okay. If you wanted to store that, this is how you're going to write this. Is this thing clear? Or if you don't want to store this, what's that?
Globally possible.
Yeah, it's going to be a part of the object. That's what I meant. Finally, you want to close this file, right? File.close. Okay, so let us test this out. Right after we do this hello IP. We have a new class, right? Bitmap. Let us just say that this is called B, or bitmap. Okay, that's just me writing Java programs in Python. It's not like that. Okay, bitmap equal to bitmap is what we write. Okay. And it's really hard for me to come out of what I know already. I start writing the variable type or class name. It's just not like that. Bitmap dot read file, and this is where we pass the file name. What's the file name? Test.bmp. Okay, so this is the first test. Reading from test.bmp, file size this, and then the other one stuff are coming from here. Okay. So what else are we going to do? We read the file size, and then what's next? We need to know the width, the height, and everything else, right? The file size is already known. We don't need that. So the width and height, we do need to compute that, and we are going to store them as what? As self, because these are important stuff that we may need to access from time to time. So self dot width self dot height. Okay, and in order to do so, we need to call this convert to integer method. So convert to integer is a method that I have written over here, but if I want to make this thing a part of this class as well, what do? Indent that, and also put self in here. So I'm calling this convert to integer, not this one. How do you know? Well, that's self dot, and that's probably one of the things I'm starting to hate already, because in Java, I mean, it was very obvious that which one you're calling. But anyways, I mean, it has its advantages and maybe this one is disadvantage. So if this is okay, the self thing is okay, we can then test this out by saying bitmap dot height and width. Let us just print that out. How do you print the height? Bitmap dot height. Okay. There is no such thing as encapsulation over here. That's another thing I'm probably hating. Okay, so let me comment everything out just to keep things simple. And this get color, we will come to this. This convert to end. These are some old stuff that we have written. I'm commenting them out as well. So this is my class that I'm writing right now. And so far, let us just see that if we have got the height and width. Right, we haven't. Byte array is not declared. Where is my byte array? This thing. Okay, so this byte array is not declared. Yeah, obviously. We are trying to read from this. We know the file size. So what was the next thing we did? Byte array equal to byte array, and then file dot read. How many bytes? File size number of bytes. That's when your byte array gets created, not before that, and that's why it failed. This byte array, I want this thing to be a part of this thing, so that's why it stays as self. And so we should remember so it checks out, right? And I guess I can yeah, well, let us leave these things for now as debug information, and as we're doing this I will cancel them out from here. While we're at it, please sign your name. Which one? Oh, I selected everything and hit Control and slash, the one that you use for division. Okay, so this is for image processing. Since we have two classes back to back, please sign for 2 entries. It's the same date, but 2 entries. All right, so far we have managed to read all these things. Okay, what else do we need? After height and width information, there is another very important thing that we must maintain. What's that? That's the image offset. Okay, the data offset, this is a very crucial piece of information for us. So we need to keep that here, and that should also be a part of self. So self dot this and self dot that as well.
So one thing is this self thing is claiming us that it is under the read file. This parameter.
No, it's for the entire object.
The entire object, right? So if we have multiple of these,
They will have different values for each of these things, just like in Java we had that. So for one class you can create 1000 objects. Each of those objects will have their separate width and height and a byte array. So all these things that you have with self, they are going to be attributes for that. Now we have this data offset over here. Now that this is done, this is going to be quite convenient for us to write this get color, or actually this should be written as get pixel. So I'm going to write that right in here. So you can select a bunch of lines, Control Shift slash, well, yeah, Control slash, I think that's a toggle thing. Control slash, it comments things, and you can take it off. So we indent this, and then we say that this is self, and we don't need any of these things anymore. We pass the self, we pass the row and column, the rest can be computed. The data offset, we already have that from self, right? The row, we know that from, well, not that, sorry. The width we know from self. The row and column is something that you're passing. The byte array comes from self. And that's it. And you just throw it back. So now that we have rewritten all these things, if you want to print pixel 00, you could just say bitmap dot get color row and column 00, just like that, and say 000, because the first pixel was a black 1. Or if you go with 199, here we should get 00255, and that's exactly what we get. Okay, so right now I'd like to change this naming over here, get pixel, and I'll change it up here as well. Pixel, and just to make sure that this works, it does. Okay, now that's a lot cleaner. Okay, so we got a class, we can read a file. It doesn't do anything fancy, we can just read the individual colors, and just to do that I think I have killed the class, the whole thing. It's already 11:56, so 2 hours gone, just doing these things. So, like I said, that we can do a lot of interesting things, and some of these things I'm going to leave as homework for you guys. Okay? You'll have to Google a bit to learn how to do a certain thing in Python, but it's not going to be too difficult. Actually, let me do this one so that we can have some fun exercises. Let me see. If write file, self and file name. How do you write to a file?
Just write
Yeah. What else? And then try doing this. Try file dot write. File dot. File dot write, and there we can go that byte with the byte array. So self dot byte array. It should be just like that. Let me try this out. Finally, file dot close. So we have this test.bmp. Excuse me. We have this test.bmp file, and I want to write a copy of it to some output.bmp. Alright, just to test whether this is working or not. And I don't know yet. We have an output file which is exactly the same, so it works. Is this thing clear? Okay. So if you understood this thing, let us start with the very basic. These are going to be your homeworks. Just like we had getPixel that returns us red, green, and blue given the row and column, it will be very handy if you have a analogous setPixel where you pass the red, green, and blue values, and then you do the rest. Okay. Alright, so you got to do something over here. Alright, replace that line. Understand how we did this getPixel. You have to identify that particular pixel, go to those bytes, change the values, change the red, green, and blue values, and then rewrite that, and maybe it doesn't change. Okay, just to give you an example, this is probably not going to be too visible, but let me try. We know that the byte offset is what? 122, right? This dot byte.
So this.
It's going to take some time for me. Not 0 though, 122, 123, and 124. Okay, so I want to put a white pixel. Or actually, let us do it this way. Okay, so whatever we pass is going to be at the bottom left corner. See, this pixel's color is going to change if we manage to do this. So right before writing this out, what if we do set pixel and then at 0, 0, let us try a yellow color. So red and green, we put 255 over there, but 0 for blue. So it says do something, maybe it did something, right? Let us open this up, and yes, it did work. It's hard to notice, but let me open it up with GIMP. It didn't come out to be yellow though.
Cyan.
Yeah, it's cyan because of the way we wrote that. So I made a mistake. It is supposed to be 124 over here and 122 down here. So if you do that, then now it should work. Let's try this one more time with GIMP. Yes, we do have a yellow dot. I could see that. Right over here, that's a single pixel that's yellow. So that's a demo that I showed you how to write a single pixel over here. Okay. Let us do some more fun stuff as homework since you have some time to kill. We don't have any more classes in the entire week. So homework number 2. Okay, and it will increase the entire brightness of that image, like with that percent. And we can do a lot of stuff. We can write a whole new image processing tool. So you can make everything grayscale, and you can have a person wearing a red hat. Just that red hat will remain red. You can create a lot of filters. So we'll look into some of the fun applications later on, but we need to understand how these things are working. Please make sure that you understand this code and you try these things on your own. For some of you, and also for myself, this is a new language, or a language that we don't write code in, so it may get a little bit difficult, but with practice, it shouldn't be too much of a problem. Any question about any of these things? No? All right. Yeah, I'm going to upload this thing on GitHub. Well, Java code for bitmap reading shouldn't have been too big either. I mean, that's not. But for OpenCV, it's going to make a difference.
OpenCV should be short, right?
Yeah, it should be. Okay. So.